Hi again, folks. In this video, I'm going to look at deriving the Hicksian demand. And if you recall, Hicksian demand comes from the consumer's expenditure minimization problem. So consumer is going to minimize the sum. So I've already set up the Lagrangian here. The sum of the expenditure on each good. And there's going to be some Lagrange multiplier. Taking some level of utility is given. So this is where the utility function comes in. So we write the utility function here. And some arbitrary level of utility I'm just going to call u bar. You can differentiate this with respect to xig to find the minimizing level of demand, of expenditure, sorry. And we get that PG, I'm going to simplify everything already. So we get mu I is equal to A, 1 over sigma minus 1, alpha G xig minus 1 over sigma. Or rearranging xig Hicksian, I'm going to denote it with an H there, is equal to mu I to the power of sigma times alpha G Pg to the minus sigma times u bar. So again, Hicksian demand. Remember, Marshallian demand is just a demand function that's only a function of prices and the consumer's income. Hicksian demand is a function of prices and utility. So I'll call this function some function. G is not a good letter to use. Let's call it function H for Hicksian. It's just a function of P1, Pg, and u bar. We don't have this quite yet. We have a mu I here that we need to substitute out. And I'm not going to show you how to do that, but it's similar steps to how we derive the Marshallian demand. So you're going to need to find some way to substitute out this mu I. And you should also find that in attempting to do this, you'll find that mu I is equal to the inverse of the lambda I that we had in the consumer's utility maximization problem. So they are inverses. And if you are able to do this correctly, you'll find that the Hicksian demand is given by the following equation. Okay, so Hicksian demand, and you should again derive this for yourself, is just a function of all the prices. Again, we have a sum over all the prices here, and some arbitrary level of utility. Now, we can also calculate the elasticity of demand with respect to a change in the price for the Hicksian demand. I'm not going to derive this for you, but I will just tell you that the own price Hicksian elasticity of demand, which is just defined as the percentage change in Hicksian demand with respect to the percentage change in price, is just equal to minus sigma plus sigma pi g, where again the pi g is the budget share. So you should try and derive this for yourself in the same way that we derived the Marshallian elasticities of demand in the previous video. The cross price elasticity of Hicksian demand. Also, you'll find that this first term drops out and we just get sigma pi k. So remember from the previous video that the own price elasticity of Marshallian demand was just equal to minus sigma plus sigma minus 1 pi g, and the cross price elasticity of Marshallian demand was just equal to sigma minus 1 pi k. Clearly we can now write the Slutsky equation in elasticities. So remember, the Slutsky equation tells us how the substitution effects and the income effects combine to give the total effect of a change in price on the change in demand. Although we're writing in elasticities now, so let me just write that. Total effect equals substitution effect and the income effect. And we can see that the Marshallian, so this is the effect on Marshallian demand, total effect on Marshallian demand. The substitution effect is the effect on Hicksian demand. And this income effect is going to be a function of the budget share of the good that's changing in price. So our Marshallian own price elasticity is just equal to the Hicksian own price elasticity minus the income elasticity of the good, which remember we derived in the previous video, and in the CES case we found was just equal to 1 for all goods, multiplied by the budget share. For the Marshallian, we have minus sigma plus sigma minus 1 times pg equals the Hicksian, which was minus sigma plus sigma pi g, minus eta, which was just 1 pi g, and so we can see they're very clearly the same. And likewise, the cross price elasticity of demand, Marshallian demand, is equal to the cross price elasticity of Hicksian demand, the substitution effect, again, less the income effect. So I think it should be eta k times pi k. And again, we see that that is exactly what we have up here. So this was sigma minus 1 pi k, and this was sigma pi k, and eta being 1 is just minus pi k. So again, that's correct. So hopefully this was useful and is informative about the nature of the CES utility function and what it means for demand. I've shown you how to derive some of the elasticities of demand, at least in the Marshallian case, and I've told you what the elasticities of demand are in the Hicksian case, and I leave it as an exercise to you to derive them yourself and convince yourself that the Slutsky equations here, which relate the two elasticities of demand, does in fact hold in this case. Thanks very much. I'll see you in the next video.